Good day, everyone. I am John Jesus, the mini Einstein. Welcome to Maths World. I will be introducing you to logarithms. What do we mean by logarithms? From this, we can say that it has some dictionary meaning, but let me tell you the etymology of these logarithms. These logarithms comes from two Greek words, which is logos and arithmetic. And we all know that arithmetic means number itself, but logos can mean anything also. But here it means ratio or proportion. The Scottish mathematician John Napier is the one that brought out this. If you now see log any number, let me use a number. Let's assume log 10 base 100. It is actually asking you a question that how many times can this 10 be raised to the power to give us 100? That is what it means. Log 10 means how many times can this 10 be raised to give us the power of 100. For instance, it can be raised in 2 times, right? Because 10 times 10 will give us 100. So this guy can be raised in 2 times. So we can say that the answer is what? 2. But we will learn how to solve this better in the video. But I'm just introducing you to how we do it. So he brought out so many theories on this, laws when civilization comes. He brought out so many laws, and some of the laws are the one we will be discussing now. Let's go. This is the first law of logarithm. It says that log b base a plus log c base a is equal to log b times c base a. It actually means if these logarithms that we are adding together are having the same base, look at it very well, they must have the same base. If they are having the same base, now you will take one out. After taking one out, we now multiply these two numbers. This plus we change to times. Do you get? For instance, now if you have log 42 base 2 plus log 2 base 2, what we are going to do is to multiply this and this together. Because they are having the same base, I'm taking one log, which is what? Log base 2. They are the same. This is plus. I will multiply this together. 42 times 2. Then you calculate on, which will later give us 4284. Are you getting it now? The second law states that log b base a minus log c base a equals to log b over c base a. It's like the same thing like this, but minus changes to division. But note this very well, whenever they are having the same base. If they are having the same base, just take only one log base out and divide this number. So let me give you one example. It will become log 42 over 2. Since we are subtracting them, the minus will change to division, and they are having the same base, we are taking only one out, and log 42 over 2 is 21. So this will be our law. Number 3 now, log a base a is equals to 1. So if you are having a number and you are having another number, that same number as your base, your answer is always 1, which means the question, remember what I told you, the question states that how many times can we raise this a to give us a, which is only 1 times. A raised by 1 is still 1. That's why a base any number, that number is still 1. Let's move to the next one. The next one states that log 1 base a is equals to 0. Whenever you are doing log 1 base any number, it is always equals to 0. Why? Let me just prove that in just 2 minutes. Now we have log a and 1. Remember the question, how many times can this a be raised to give us 1? But remember that any number raised to power 0 is 1. If you have not watched my video on how I prove that any number raised to power 0 is 1, go and watch it. Now I can now represent 1 as a raised to power 0 because I know that a raised to power 0 is what? Is 1. So I can bring this one to the back. Is one of the law. That is the next law that I will write now. I can bring this one to the back and become 0 times, it will become 0 times log a base a. Log a base a is 1. So 0 times a1 is what? Is 0. That's why whenever log 1 base any number is in, it is equals to 0. The fifth law states that whenever that number is carrying something, we just bring that number to the back. The power is the one we are bringing to the back. The power of this one is the one we are bringing to the back. Now log b raised to power c base a will become c log a b base a. For instance, if we can see the example now that the 4 is carrying a power of 8. So I brought the power to the back, and this 4 and base remain the same. Remember, it is multiplying this thing. 8 times this is still that number. Okay, the next law is actually the relationship between indices and logarithms. If you should look at this guy very well, it looks like indices. Yes. And if you want to do this x that we are looking for, the power will become a number, and it will become log. This number that is carrying this power will become the base, and y will become the number back. What we actually did there is to impute to prove this. Now n raised to power x equals to y. I can say that I should introduce log n to both sides. I can introduce log n to both sides such that this can come down and log n base n will become 1. So if I should introduce log n to both sides, it will become, you can see I've introduced log n to both sides. So I can now bring this one to the back. It will become x log n base n according to this law equals to log y base n. Remember, log n base a is 1. So log n base n is also 1. So it will become x times 1 equals to log y base n. So x times 1 is x. Log y base n. You can see that I've actually proved it. So you don't need to be solving like this, and if you can go through. But what you need is to bring this down, the power of this guy down, and equals to this one that is carrying the power should become the base, and put y there. This is the 7th log. Log c a base a raised to power b. You can see that the base is the one carrying power here. So this power is now going to move to the back, and when moving to the back, it is going to turn to the inverse of that power, which means 1 over this b log c base a. That's just it. So example now, let's just take one more example and see. So if you have log 2 raised to power 4, or let's assume we have log 4 base 2, what is now going to be? We will know that we can write this in power of this. So we can write it as log 2 raised to power 2 and 2. We can now bring these 2 to the back. It will now be equals to, these 2 will now become the inverse, 1 over 2 log 2 base 2. But remember, log 2 base 2 is 1. So 1 times half, it will become 1. This is 1 and it goes to half. That's how you solve question on this. So my next video will be the question, will be on questions on this law. So take your time and study this 7th law very well. Thank you.